Greetings. Welcome to Introduction to SQL for Excel Users, Part 14, More Dates. I am your instructor, Dave Langer. Here I am in SSMS, and there won't be any Excel in this video because there's not a lot of value to just flipping over Excel for a couple of date calculations, as we'll see later. So all this will be done in SSMS, but all the concepts we've basically covered before. And we'll just be focusing mainly on one thing today. The last video introduced dates, how SQL handles dates, language neutral date literals, that sort of thing. And today we're going to introduce you to the mighty Dateif function, which allows you to calculate elapsed time between two dates. And that's what we need to complete the RFM, the recency, frequency, monetary analysis that we started back in video 11. We're going to finish that up today. We're going to do the recency aspect. So what you can see here is one of the final queries from part 11 of the series. And if I just run this real quick, you can see what we saw. This was essentially an FM analysis because in part 11, we hadn't covered dates yet, and more specifically, we didn't have the ability to do elapsed time calculations. We're going to fix that today. So you can see here customer keys and the frequency score and the monetary score from a rank of 1 to 10. So what we need to do is start taking this base query and enhancing it so that we can get more and more goodness out of it, so that we can complete this part of the outer query and add one more section of SQL here that gives us the recency score. So first thing we need to do is we need to leverage the max aggregate function. So as we've talked about previously, in Excel, when you create a pivot table, there are summary functions that you can use in the pivot table, and they will create things like counts and sums and averages and min and max and all those sorts of things. Those functions are group aware. When you group something in an Excel pivot table, and you apply one of those summary functions, it actually says, okay, for each group, I will find the min value or the max value or the average or whatever it might be. The analogous functionality of that in SQL is an aggregate function. And what we have here is a usage of the max aggregate function, which works conceptually exactly like finding the max value of a group in an Excel pivot table. Now, in particular, what we need to do is we need to enhance the customer sales order CTE. From last time, we had this right here, which says, okay, for each customer key sales order number combination, for each grouping of customers and their individual orders, go ahead and calculate the total amount of the sales for that particular sales order. Because what we saw in the previous video, in video 11, is that this table, Fact Internet Sales, is set up where we'll have multiple rows per sales order number, one for each product, one for each order line that constitutes the order. So if I ordered 4 different products in one sales order, this table would have 4 individual records for me, one for the sales order and product combination. So we need to group those together, and this allows us to get the total amount of each sales order. And what this little piece of magic allows us to do is then say, okay, cool. For each individual combination of a customer key and a sales order number, grab me one order date, and it should be the largest one. Now, generally speaking, the order date is going to be the same across all of the rows for a sales order number inside the Fact Internet Sales table. But what we need to do is we need to just pick one. And of course, we want the most recent one. So for whatever reason, there happen to be multiple order dates associated with a single sales order number, this one would pick the largest, which is what we want, because when we're doing a recency analysis, we want the most recent date. So this makes everything work out just fine. So if I go ahead and just run this, I can show you a sample of the output here. And there you go. So for customer 15084 and their sales order 54147, here's the total sales amount, and here was the order date. Now you'll notice that all of these times are blank. And that's because in the database, if we go over here and open it up, and take a look at the actual fact internet sales table, we will see that the order date column here is a date time, but apparently there are no timestamps in it. And just to confirm that, we can just go ahead and open up that table real quick, and we can go take a look at the order dates. And sure enough, even though this column is typed, you can see here, order date, even though it's typed as a date time, for some reason, there are no time aspects. Now remember from the previous video, video 13, we talked about how this is important. If you do not provide a time aspect for a SQL date time, you only provide the date aspect, what you're going to get is an assumption that these are all midnight. Now that's going to be important. We need to remember that because when we do our date calculations, we need to remember, hey, all of our order dates assume a time of midnight. So we'll need to incorporate that into our date logic. Okay, moving back over to SSMS here, moving back over to the query window here, we can see here that we've got the first step in place. Okay, so if we run the entire query all over again, nothing really changes because this thing that we just added has not been added to subsequent pieces of SQL. So let's go ahead and take care of that. So what we have now is every individual customer order. That is, every combination of customer key and sales order number has the order date associated with it. Sweet. So the next step is we need to further enhance this query by then adding the capability of finding the most recent sales order for each individual customer. Because now we have the CT that says, look, for every customer, here's all of their orders, including the dates that the orders were made. And now what we need to do is say, oh, okay, for each individual customer, see how we're in this CT here, we're grouping by customer. For each individual customer, add up all of the money they've ever spent, right? Because this is for the monetary aspect of the RFM analysis. How much money has the customer spent with AdventureWorks throughout time and space? Sweet. And then for the recency score, out of all the orders each customer has made, just find me the max order date, which would be the most recent order per customer. This gives us the data that we need to calculate the R score. And lastly, of course, there's the count here from video 11. And that's just basically how many orders across time and space have the customers made with AdventureWorks. So this gives us all the raw materials that we need for doing the RFM analysis. And as you can see here in the outer query, as we saw in video 11, this is all we need to calculate the monetary score and the frequency score. However, this query alone, if I run it, you'll notice that the output doesn't change because this alone is not enough for us to do the R score. We have the most recent order date for each customer, but we still need to actually do some further calculations so that we can actually use NTile to create a recency score. And what we need to do is we need to figure out the elapsed time. How much time has gone by since the most recent customer order and right now? And we will use that elapsed day count as the score for NTile to figure out. Because obviously what we want is folks that ordered yesterday to have a higher score than folks that ordered 6 months ago. Okay, so to do that, we're going to need the mighty Dateif function. Okay, so Dateif is awesome. It's an awesome, awesome function. So let's go ahead and actually take a look at this. Let's go ahead and find this, shall we? Let's go T-SQL Dateif. Okay. And here is Microsoft's documentation for the mighty Dateif function. And I won't drain it for you because we're going to take a look at it in SSMS. But generally speaking, what you do is you call the Dateif function in SQL and you pass it a date part. Do you want a minute? Do you want an hour? Do you want days, months, years, what have you? It's a very flexible function. You can use it to figure out all kinds of elapsed times between a start date and an end date. Now, as we learned from last time when we talked about basic dates, the fidelity, how accurate this thing can be based on a date part is going to be wholly dependent upon what kind of date type you send it. So for example, if you want to know elapsed minutes, let's say, if you want date part of minutes, then these date times that you send in there, these date objects, these date values that you send into this function better have a time aspect. Because if you want minutes of fidelity and you don't have minutes in these things, then it's not going to work out. That's why type matters. That's why in the last video, I went on and on and on about the importance of date types. This is the reason why. Your date diff logic is not going to behave as you expect unless all of the constituent pieces you need are there for the calculation. Okay, enough of that. So let's go back to SSMS here. So here we have the date diff function being called 3 times. And you'll notice that I'm calling it for day, month, and year. And what I did was I just picked some arbitrary dates. So I picked January 1st, 2018, and then I picked January 1st, 2020. And notice that I am assuming midnight here for all of these dates. The 00:00:00. I'm assuming no time aspect, which is totally fine because the fidelity I'm looking at doesn't really matter, right? I'm not looking at elapsed seconds or elapsed minutes or anything like that. If you're actually just working with whole days, the time aspect won't matter so much, generally speaking, as long as you're keeping everybody at midnight so that everyone's on even footing. So let's go ahead and run this here. And you'll see the output down here of 730 days difference, which is 2 years, 365 times 2, 730, makes sense. 24 months, once again, makes sense. And 2 years. This is all great. And by the way, just so that we're clear, in a future video in the series, we'll talk a little bit more about the intricacies of like, if you actually have some of your dates don't have a time component and some of them do, how do you handle that? But that's beyond the scope of this video today. Okay, so this is the base idea. Notice how date diff calculates all kinds of cool stuff for us. This is awesome sauce. Love it. Now here's the thing. Date diff gets even better. It's even more powerful in combination with the current timestamp function. Now, if you remember from the last video, the current timestamp function works like Excel's now function. It returns back the current date and time on the computer in question. In this case, it is the computer that's running SQL Server. So for example, if you follow the instructions for this tutorial, you're running SQL Server either locally on your laptop or your desktop or on a VM in the Azure cloud. Either way, current timestamp is going to talk to SQL Server, which is the machine that you're working with, and it'll return you back the date and time of that machine. Now, the reason why I'm bringing this up is that in the real world, in a production environment at a large company, let's say, usually the SQL Server is sitting on a different machine from your laptop. And depending on where that machine is sitting and where it's configured, the current timestamp might not be what you expect. So for example, let's say you work in beautiful Bozeman, Montana, where I live, and your SQL server, the actual SQL Server database machine that you're communicating with, is actually located in a data center, let's say on the East Coast of the United States. And let's say, for example, that server is configured with East Coast time. When I pull back a current timestamp, I'm going to actually get the timestamp of the server that's running the SQL Server process. And since that's in the Eastern time zone, I'm going to get a timestamp that's 2 hours ahead of the timestamp I would get on my local machine. Just be aware that these date functions work with the timestamp of the machine where SQL Server is running. Okay, excellent. Now, date diff, the combination of date diff and current timestamp is like chocolate and peanut butter, man. They are better together because what they allow you to do is calculate elapsed time. So you can see here, I'm doing the same thing, basically day, month, and year, but I'm keeping the beginning date the same, January 1st, 2018 at midnight. And then I'm saying, look, what is the date diff between this date and the current timestamp as measured in days? And what this is going to tell me is what is the elapsed number of days from January 1st, 2018 at midnight and the current timestamp on my computer, on my laptop. So if I run that, Notice now I'm going to get different values. 1,007 days, which makes sense because at the time of this recording, it is, you can see here, October 4th, which is more than 10 months into the year. So of course it's going to be higher than the last query because the last query assumed January 1st, 2020. And notice that the diff in months is 33 and the diff in years is still 2 because it's going to return back only complete, full, elapsed years. All right, so this is awesome, okay? This is what we need to do to finish up the RFM analysis. We need this kind of logic added to our query to then calculate, hey, of a customer's most recent order, how many days have elapsed since that order? And that will be the basis of our entile scoring of the recency aspect of the RFM analysis. Okay, let's go ahead and scroll down here. And you can see here what I've done is I've said, okay, I'm going to use the Dateif function right here because what I need to do is calculate the elapsed days by customer. So I'll do it in this CTE right here. I'm going to invoke the Dateif function. I'm going to say, okay, give me the number of days, please. The number of days that have elapsed between the max order date, right, the most recent customer order date, and the current date. And I would like you to call that resulting value the elapsed days to most recent order. So this is great. So I can run this query, and once again, I'm not going to see anything change. It's just going to be what we've seen before. It's still just the FM analysis. But now this is the piece of data. This calculation, this count of days is exactly what I need to then alter this outer query to now calculate the recency score in addition to the frequency and monetary scores. So that's easy to do. You can just scroll down here and boom, right here. So notice that it looks almost exactly the same for the recency score calculation as it is for the frequency and monetary scores, with one exception. Notice that it's descending. And why is that? Well, because we want dates that are smaller to have higher values, right? Because like we said, if a customer bought yesterday, they should receive a higher score because they have a more recent purchase than a customer that bought 6 months ago. So what we need to do is we have to stack rank these in descending order, because what that does is that makes the smaller numbers lower in the list. Lower in the list means a higher entile score. So for example, I can just run these bad boys right here and boom. Now notice this. Notice all these 1010s, right? On the F and the M. Oh, most of them aren't doing so hot in the recency score, except for this guy right here. Customer 11,001. They got a recency score of 9, which is pretty good. But notice most of these other guys, just sad. So these guys purchased a lot of different orders, and they spent a lot, but they haven't bought anything recently, which means that generally speaking, they're not going to be the creme de la creme of our customer base. And once again, I'll use the analogy that I used in video 11, which says, look, maybe we're trying to figure out which customers AdventureWorks should send big, beautiful, colorful catalogs to in the physical mail by the post. Generally speaking, printing those catalogs and shipping them out is very expensive, so you only want to send them to your best customers. Well, technically, this is not one of your best customers. They bought a large amount of product and they had a good number of orders, but they haven't bought any time recently, which means that you probably shouldn't send them a catalog, which then says, okay, cool. Well, what customers should I be sending the catalogs to? And we can just alter our query real quick to make that happen. So here's a version of the query that's set up to only return back the 10, 10, 10s, the creme de la creme of our customer base. Now notice here, we have 18,484 rows, right? So we have 18,484 customers. Let's see how many of them are 10, 10, 10s. Now to do this, as we saw in video 11, all I need to do is take the outer query, right? This was the outer query, and just wrap that bad boy up in another CTE, just like this. So I get the recency score, the frequency score, and the monetary score. This virtual function, not virtual function, the virtual table that's produced by this CTE now has a name So I can then create a where clause and filter on only the 10, 10, 10s. Right? And let's say I want to run that. And out of 18,484, I get back 78 customers that are the creme de la creme. 78 creme de la creme customers. Let's say, for example, you're the data analyst working in the AdventureWorks marketing department, and you come back to your boss and you say, yeah, we can send out 78 catalogs, boss. That's probably going to make your boss pretty sad because 78 catalogs is not a lot. So your boss says, go back, we need more customers. And maybe you say, okay, cool. What I'm going to do is say, look, if anybody has a combination of 8 or more in all 3 scores simultaneously, that's a good enough customer to receive a catalog. So I can just easily change the query like this, and I can pull back how many customers actually qualify with these relaxed restrictions. And you can say, okay, boss, 683 of our customers are worthy enough to receive a catalog because based on their purchasing history, it's likely that that's not wasted money to send them a catalog. It'll likely incent them, motivate them to purchase again, and that's a good thing. And your marketing manager says, sweet, awesome, you did great. And you're off and running. Okay, there you have it. 100% complete RFM analysis using the power of SQL. And notice that even though this database that we're using is a sample database and is relatively small, we saw like about 18,500 customers, these techniques that you've learned so far can be scaled up to millions of customers, tens of millions of customers, however many customers your business has. Because what you're doing is you're relying on the power of the database engine to conduct these analyses. You're not leveraging Excel and its limitations. You're using the big, beefy database server to do all this for you. And it's just awesome. Okay, that's it for this video. I'm hoping you're enjoying the content. I'm hoping you're finding it useful. If you are, please subscribe to the YouTube channel because I will be producing 2 videos a week for the foreseeable future. And until next time, please stay healthy, and I wish you very happy data sleuthing.